Hi there, this is exercise 8B on Maclaurin expansions again. Remember last lesson we looked at the sin x Maclaurin expansion. I think we actually did a couple more terms. We went up to x to the 9 over 9 factorial from memory. But we basically got this same idea that what is effectively the standard sine graph, which looks like this black line here, that carries on and goes like this, is can be approximated within certain degree of accuracy by this new Maclaurin expansion. Now we've already done something similar to this with binomial expansions, but this one theoretically is really accurate as long as you have enough terms, and this one's only got 3 terms, so it's less accurate than the one we had last time, which had 5 terms, went up to x to the 9. And theoretically, I remember saying that if you have an infinite number of terms, if that's possible, you'd have an infinitely accurate polynomial. So these are the Maclaurin series expansions that you're meant to be able to use, and these are all given to you in the formula book. This one down here, the bottom one, is actually just the binomial one that we've seen before. I've called this the 1 plus nx formula, but the others are all new. So you've got exponential, log, sine and cos. Theoretically, you could be asked to do some others, but you'd be proving those from that first principle formula that we saw last time, where you end up differentiating. So let's do a few example questions. So this first one says e to the 4x. Now obviously I haven't got a formula for e to the 4x, but it doesn't take much to realise that I've got e to the x. I can just substitute it in. So if I want to write f of e to the 4x, e to the 4x there, that will give me the same as this, but rather than writing 1 plus x, I'm going to write 1 plus 4x plus 4x squared over 2 factorial plus 4x cubed, and all that. You can see what I'm doing. It's not hard at all, and then you just got to make sure you don't make daft mistakes. So that's 1 plus 4x. This is 16x squared over 2, so that's 8x squared. This is 64x cubed over 6. 64 over 6 is 32 over 3x cubed. Oh, this one's a bit tricky. What's it? It's 4 to the 4, which is 256, divided by 4 factorial, which is 24. Alright, 32 over 3 again. So plus 32 over 3x to the 4. So I've done it. I've written the expansion out. So let's just check my answer. 1 plus 4. Yeah, that's right. Now notice I've also quoted the validity of this thing. And that only comes from this bit here. This says this formula works for all values of x, so as long as I have enough terms, of course. Okay, now we sometimes have to use a few tricks, and I've shown you one already, which is a fairly obvious one. Sometimes it's less obvious. So here, the trick I'm going to use here, well, it's a sine thing, and I've given you the formula for the sines, but it's sine of something plus something. Now this is actually a trick from A-level maths. And it's sine of a plus b, it's an identity, and the rule says it's sine a cos b plus cos a sine b. So if that's true, now let's just do some stuff here. So this becomes sine x plus pi by 4 is equal to sine of x cos of pi by 4. Now cos of pi by 4 is something we know what it is, plus cos of x sine of pi by 4. Now pi by 4 into cos and sine is actually the same answer. It's root 2 over 2 sine x plus root 2 over 2 cos x. So I think this formula is going to be useful now. I didn't expect it to be, but suddenly it is, because I've got both sine x and cos x in. So I can do the root 2 over 2 bit. I'll take that as a common factor. What's it say up to? It says up to the x to the 5th term. So luckily, this goes up to the power 1, to the power 3, to the power 5 for this one. So sine x is just x minus x cubed over 6 plus x to the 5. 5 factorial is 120, plus, it says, now the cos x. Now the cos is 1 minus x squared over 2 factorial, which is 2, plus x to the 4 over 4 factorial, which is 24, close bracket, because I want to go up to the x to the 5. So I can kind of join these together. I can say it's root 2 over 2 times by, well, just put them in order, I suppose, 1 plus x minus x squared over 2 minus x cubed over 6 plus x to the 4 over 24 plus x to the 5 over 120. Just check my answer. And that looked almost identical. So, and then again, validity-wise, both of those formulas said all x, all x. So it's no surprise that I've said x belongs to the real numbers for my validity. So that's the second example. Let's have a look at this one. It gives me a hint here. It's f of x equal to the log of 2 minus 4x. And it says you'll need to split the logarithm using multiplication to get it into this form. So that's my hint, and it comes about because the fact that this is the only formula I know I'm given for logarithms. It's a Maclaurin expansion, it works really nicely, but it says log of 1 plus something, and mine doesn't say that. So it says make it equal to that. So let's do a little trick then. I'm going to write the log of 2 minus 4x. And I just notice I can factorize it, and I can factorize it as 2 lots of 1 minus 2x. And using the hint that I got given, that's the same as the log of 2, well, plus the log of 1 minus 2x. And this, of course, is now into this form. So this equals the log of 2 plus, well, what's my formula says? It says, well, when it's 1 plus x, it's that. So I've just got to rewrite it. So rather than x, I shall write minus 2x minus 2x squared over 2 factorial plus minus 2x all cubed over 3. I said factorial, it wasn't factorial. So this is log 2 minus 2x, and that's plus, so that's divided by 2 gives me 2 again. I think it's minus 2x squared, and this is minus 8x cubed over 3. Yeah, oh, I wanted an extra term. It says up to the 4th term, which, well, obviously that would have been minus 2x to the 4 over 4, which is 16 over 4, which is, oh, and it would also have been a negative, yes, plus minus, so it does give me eventually minus 4x to the 4. Now notice this one, on this one the validity is a bit like the binomial one, it's between 1 and minus 1, so that's another way of saying mod x is less than 1 is normally, but of course my x isn't x, my x is minus 2x. I'm going to write mod 2x, in this case is less than 1, or mod x is less than a half. And I don't mind which way you write it, I think that's quicker, so that's why I do it that way. So a third possible potential problem is where you end up with a product, and here you can see I have got a product. It says find f of x equals e to the 2x times by cos of 3x. And I suppose the trick here is simply just to say, well, I can do both of them. Let's do the first one, e to the 2x equals, well, if I put it into there, I'd get 1 plus 2x up to the x to the 4 term plus 2x squared over 2 factorial plus 2x cubed over 3 factorial plus 2x to the 4 over 4 factorial. That's fair enough. So if I do it here, I get 1 plus 2x. I think that's plus 2x squared. This is 8x cubed over 6, which I think is 4/3 x cubed. And this is 16 over 24, which is 2/3 of x to the 4. Now, I do the same thing with the other one, cos of 3x. And what's that give me? Well, I'm just really putting 3x into here. So it's 1 minus 3x squared over 2 factorial plus minus 3, was it plus 3x? Yeah. 3x to the 4 over 4 factorial. And if I work this out, I get 1 minus, looks like 9x squared over 2, plus 3 to the 4 is 81, over 4 factorial is 24, 81 divided by 24 equals 27 over 8. X to the 4. So now my job is to multiply these together. So if I'm going to do that, I've rewritten them out here just to save a bit of time. So I've got to times these two things together, because this obviously means times them together. Now if I do that, I only want to go up to the x to the 4 term. So just using a bit of logic, that times by all of those will give me it. So I will get 1 times by that. I'll get all three of these terms. I'll get 2x, and if I times this one, it'll go to higher power. So I think I'll get plus 2x minus 9x cubed, because the 2's will cancel. And then, yeah, I can times the same ones again, plus 2x squared, when I do the 2x squared times these two, minus 9x to the 4. And I reckon if I times this by any, well, I think I can only times it by the 1 and this by the 1. Similarly, otherwise I get too high a power. So I think I get plus 4/3 x cubed plus 2/3 x to the 4. So I just got to count up how many of each I've got. I've only got a 1, so that's that done. Oh, it's 1 minus, is that 9 over 2? What was that? 1 times 9 over 2, that should have been x squared. I missed my x squared. It's nearly a bad mistake. So the 1's gone anyway. I've got a 2x there. Now my x squared I've got there and there. So effectively I've got 2 minus 9 over 2, which is minus 5 over 2. So that's got rid of that one and that one. My x cubed, so I've got minus 9 of them. I've got plus 4/3 of them, I think. Minus 23 over 3. That's that one and that one done. And lastly I've got 27 over 8. Minus 9 plus 2/3, which is minus 119, not very nice, over 24 x to the 4. So again, it doesn't ask me for validity here, so let's just see if that works out right. It actually does look quite close, doesn't it? Yes, it does work out. So we also get questions. This is the 4th type. Functions which require 2 Maclaurin expansions, and I'm not going to get through all this, so I'm going to do a second part to this PowerPoint, and then I think there's a couple of examples still to go, and then you'll have both of them and you'll be able to do the work. So we'll call that quits there, and have a look out for exercise 8B.2.